Hello and good morning, all my brilliant children and Caden in Denver. Alright, so I'm attempting to make a video in order to help you with your assignment this week. And congratulations on making it this far. And so I wish everyone the best and hope you bring home a first place trophy. Alright, let's begin. And you can relay this message to Jake and Ty whenever they wake up. All right, so what you're going to need is your chemistry book, a piece of paper, a pencil, and you're going to need the table 2 that's on page 226 in your book. So table 2. All right, so we're going to pick up where we left off before the break. And so we were naming, using systems of nomenclature to name binary ionic compounds. And then we were using the stock system. If you remember, the stock system uses Roman numerals. All right, so now we're going to look at how we name compounds containing polyatomic ions. So all the compounds that you named before contained monoatomic ions or monatomic ions. So mono is the prefix that means one. So they were single ions that were bonded together. All right, so now we're going to look at polyatomic ions. And if you remember, poly means many. All right, and if you look at the chart that's on page 226 in your book, so table 2, it says some polyatomic ions. So these are common ions that you'll find that you're going to be having to name, especially when you have your next test. All right, so you'll notice on that chart there are only 2 positive polyatomic ions, and that is ammonium and dimercury. All right, dimercury you'll hardly see in these problems. Ammonium is going to be the positive polyatomic ion that you'll mostly use. All right, so why do we call them polyatomic ions? Because these ions are made of more than one element. So if you'll notice ammonium in table 2 on page 226. So ammonium, it's made of nitrogen and then 4 hydrogens. And notice that it has a +1 charge. All right, then you'll notice the other ones are all -1 charges, -2 charges, -3 charges. All right, so those are the polyatomic ions that you're going to be using. All right, you can read about oxyanions in your book. Oxyanions, if you remember, an anion is a negative ion. So oxyanions are negative ions that contain oxygen. All right, so let's look at how we name these compounds with polyatomic ions. All right, so we'll begin with sample problem C on page 227 in your book. And it says, write the formula for 10,4-sulfate. So 10, Roman numeral 4, in parentheses. All right, so what does this Roman numeral 4 represent? Do you remember? So the Roman numeral 4 represents the charge of the ion, of the positive ion. So this tells us that we have 10. Remember, the symbol for 10 is SN. And I hope you can see that. Yeah, I think you can barely see it. So the symbol for 10 is SN, and its charge, it tells us there, is +4. So +4. So we put a 4 plus for 10. All right, then we have sulfate. So you've never used sulfate before, so you're going to need that table 2 on page 226, which will be available to you whenever you have a test. So look on page 226 and find sulfate. So you're looking for the word sulfate, S-U-L-F-A-T-E. So look for that. All right, and you should have found sulfate by now. It's in column 2 of the negative ions. All right, sulfate has a formula, sulfate ion. So it is SO4. And you see a superscript that gives you the charge. So it is 2 minus. Right, so a -2 charge. All right, so just like you did before with the other formulas that you wrote, you cross over the charges. Cross over the charges. All right, so we're going to write SN, and then we're going to have SO4. All right, so that means we have to put a 4 here. But we need to put parentheses. So parentheses, just like you do in math when you put parentheses, random set of numbers. So we put a 4 there to mean we have 4 of these sulfate ions. All right, then we cross over the 2. So 10 has a subscript of 2. All right, so is this in the smallest whole number ratio? So remember, we want these formulas to be in the smallest whole number ratio. And no, it is not, because 2 will go into 4 2 times. All right, so this is not in the simplest whole number ratio, so we need to erase this. So 2 goes into this 4 2 times. All right, so we have 2 sulfates right there, and we have 1 10. So 1 10 ion, and it's 10-4. All right, so that is how you do that. All right, so I'm going to do a couple of these practice problems with you, and then you can do the rest of them on your own. All right, so part of this is going to be review of things that you've already done. All right, so let's look at number 1 on page 227. Write the formulas for the following ionic compounds. All right, so we're going to do sodium iodide first. So what is the symbol for sodium? If you said Na, you're correct. All right, and sodium is in, use your periodic table if you need it, but by now you should know that sodium is in group 1. So sodium has a positive 1 charge. All right, the iodide ion is in group 17. Iodine's in group 17. So it has a negative 1 charge. All right, so we cross over the charges. Doot, 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 doot. And we don't have to write the 1s because it's understood to be 1 if there's no number there. So that's the formula for sodium iodide, Na. All right, so let's do one that's more challenging. Let's do one with the polyatomic ion. All right, so we're going to do sodium. No, let's not do sodium carbonate. All right, so we're going to do calcium nitrite, letter G, on page 227, Renee. Calcium nitrite, letter G, page 227, Renee. All right, here we go. So, calcium nitrite. So you write the symbol for calcium, which is Ca. Nitrite, you don't know. So you have to look it up in that chart on page 226. So nitrite is in the first column of negative ions, and it has a formula of NO3, and it tells us that it's negative 1. Right, calcium, you know, is in group 2, so it has a charge of +2. All right, so we're going to cross these over. Doot, doot. All right, so calcium gets the 1. And then this nitrite ion gets 2. All right, so that means we have to put nitrite in parentheses. And then we write a subscript of 2 outside the parentheses. All right, so that is how you write the formula for calcium nitrite. All right, let's do letter E, copper 2 sulfate. All right, can we make sure you're on the right one? Copper 2 sulfate. All right, the copper, we know is Cu. The Roman numeral 2 tells us that it's going to be 2+. And then we have the sulfate ion. So look in the chart on page 226, find sulfate. It is in the second column. All right, so it's SO4. And it has a 2- charge. All right, so we cross over the charges, and then we put a 2 there and a 2 there, but we want it to be in the smallest whole number ratio. So 2 will go into 2 one time. All right, so we put copper, then sulfate. All right, so we have, oh, we don't have to put anything else, so that's it. So copper, sulfate, that's it. So that's how you do the formula. All right, and then you'll do practice problems 2 where you're naming the compounds. So like B, for instance, is calcium, so 2B. So we have calcium, and then that's a hydroxide ion. So you just call it calcium hydroxide. All right, when you get to iron on letter E, so 2E, that'll be the only one that uses the stock system. So that'll need Roman numerals for that. And I'll let you work with that and figure that one out. All right, so another video is coming in just a moment.